Welcome back to the Cave of Science, and we're going to do the quantum number calculation for nitrogen, atomic number 7, so therefore it has 7 electrons. If we go ahead and do the electron configuration for nitrogen, you can see I have it written here, 1s2, 2s2, and 2p3. Again, I'm following the Hund's rule, which we'll look at at a later date. The principal quantum number is a lowercase n, and it is the last coefficient. So if we look here on our electron configuration, we've got a 1, 2, 2. 2 is our last coefficient. So 2 is going to be our principal quantum number. So let's go on and look at our angular momentum number. The angular momentum number, or L, is the last letter of the last subshell. So our last subshell is right out here. So we are at P, and we need a chart to put a numerical value to this. So if we were in the S, it would be 0. We're in the P, so that corresponds to a 1. If you were in the D, it would be 2. If you were in F, it would be 3. So L, or our second quantum number, equals 1. And let's go down and look at our magnetic quantum number. Our magnetic quantum number, or M sub L, now you're going to calculate that using this formula here, 2L plus 1. So if we were in the S, so S would equal 0. So 2 times 0 plus 1, we could only have one possible number. If we were in the P, it would be 2 times 1 plus 1. That would equal 3, so we could have 3 possible values, and we'll look at those in just a second. If we were in the D, then you can probably guess what's going on here. 2 times 2 plus 1 equals 5. And if you were in the F, it would be 2 times 3 plus 1 equals 7. So the possible values, if we look at this, and see if we can move this over a little bit. So the possible values so for the S, the only possible value you would have would be 0. If you were in the P, the possible values are 1, negative 1, 0, positive 1. If you were in the D, negative 2, negative 1, 0, plus 1, plus 2. And if you're in the F, you can probably guess what this is going to be. 0, plus 1, plus 2, plus 3. So we're in the P, so we got 3 possible values. So now if you look at our electron configuration, we can have 3 possible values, and we're looking for this one right here. So we could have a negative 1, we could have 0, or we could have a positive 1. So for the magnetic quantum number for nitrogen, the magnetic quantum number is going to be a positive 1, because we're going to look for this one right here. So this is going to be a positive 1. If we had carbon, this one would be gone. The magnetic quantum number would be 0, because that would fulfill this one here. And likewise, if you're you do the same thing if you're in the D or F. All right, let's go on down to the last number. The electron spin number. The electron spin number is pretty straightforward. You look at the last electron. And again, we're looking at this one here. And if you remember, spin up, they all will fill these suborbitals up, up, up until you start doubling them up, and then you would have the down one. Well, if it's a spin up, it's going to be a positive 1/2. If it is a spin down, and you can probably guess what that's going to be, it's going to be a negative 1/2. So for our example, we're looking right here, we got to spin up, so it's going to be plus 1/2. So now if we want our quantum numbers for nitrogen, we have to put all of these together. So the quantum numbers of nitrogen and I'll just shorten that, of nitrogen are what we found from above. Our principal was 2. Our angular was 1. Our magnetic was 1. And our spin was plus 1/2. So these are the quantum numbers for that last electron in nitrogen. So that's how you find those. Really, once you do a couple of these, they're not very difficult to do. Just kind of keep following the same basic rules. Okay, until next time.